I am going to connect this battery holder with two AA batteries between these 2 points, and the red LED lights up. Now, when I connect it in the opposite direction, although I can't really connect it because the green LED is in the way, the green LED lights up. This circuit is used to test the polarity of the batteries, because the LEDs, which are connected in opposite positions, only allow electricity to flow through them in one direction. Electricity can flow through the red LED, and now can only flow through the green LED. I'm going to turn on the slide switch, and music will play from the speaker. I'm going to blow into the microphone. And when I do so, the music turns off briefly, or at least the volume is reduced for a short moment before it comes back on fully. I'm going to do it again. You have to blow on the microphone if you want the doorbell to stop, the music to stop early. I replaced the speaker with the LED, the red LED, and I'm going to blow into the microphone. Watch the red LED carefully. The LED turns off if I blow into the microphone hard enough. And you could say that this is just like blowing out a candle. I'll do it again. It's tricky, but you have to have just the right amount of air in order to turn the LED off. I'm going to turn on the slide switch, and music will play. I'm going to let it play all the way through, and then I'm going to blow into the microphone. Now the principle is opposite of Project 176. I now have to blow into the microphone to get the music to play. Replacing the speaker with the red LED, I'm going to turn on the slide switch, and I'm going to blow into the microphone. Now the red LED comes on as long as I am blowing into it, and then it turns off once I'm done. The microphone seems to be more sensitive in the projects in which I have to blow to keep the music or LED on than to keep them off. And if this microphone was even more sensitive, either Project 178 or 179 could be used as a noise detector or voice detector, because the microphone could pick up the sounds and sound either an audio or visual alarm. When I turn on the slide switch, the fan will spin, and you can hear kind of like a buzzing sound coming from the speaker. I'm going to slowly move the lever on the adjustable resistor, and listen to the different levels of sounds you can hear. On some levels, the sounds are lower pitched, and on other levels, the sounds are higher pitched. And do you observe anything interesting? You may have guessed it. The sounds are higher pitched when the motor is spinning slower. On the other hand, they are lower pitched when the motor is spinning faster. And these sounds may remind you of something familiar, such as a race car or airplane engine, or simple buzzing sound. Or screechy tape. I replaced the C2 capacitor with the C1 capacitor, and when I turn on the slide switch, the motor starts a little bit sooner. And the sounds are supposed to be a high-pitched whine, but it doesn't sound like that to me. However, the fan seems to spin faster over most of the range on the adjustable resistor. Only on a very narrow section of the range does the fan actually stop. And the sounds, I don't know, and they might be more high-pitched on the narrow section of the range in which the fan is not spinning. But on the vast majority of settings, the motor is spinning pretty fast. And you do hear some humming or buzzing sounds, like that of an airplane or race car engine. With the photoresistor in place, I'm going to turn on the slide switch and adjust the RV and shine a bright light on the photoresistor. And I can control the whining by waving my hand over it depending on the light setting. It's pretty intense and it's very difficult to do this one-handed, but I can control the sound if I block enough of the light to the sensor. It's pretty sensitive, so this is a bright light, but if I was to cover it completely, the motor will come to a stop, or at least slow down considerably. It comes to a stop here. And then it starts up once light can reach it again. It's controlling the electrical resistance, the photoresistor. I put the C2 capacitor back in its original place, and now the humming and buzzing sounds are pretty loud, but you can see that the motor spins incredibly slow. And now shining light on the photoresistor, but I don't think the fan spins as fast as it did in the previous project. I put the C3 capacitor in place of the C2 one, and now the motor will only move in short bursts when there's no light on, when there's not sufficient light on the photoresistor. I can make it spin a little bit faster when I shine a bright light on it, but you can see it's just clicking, as if it was like a car engine or motor that will not run. And obviously it's much easier to stop it altogether if I was to block all light to the photoresistor. I'm going to turn on the slide switch, and now the circuit makes a low-pitched whining sound. And I can adjust the pitch and volume with the lever on the adjustable resistor. While the green LED appears to be on continuously, it's actually flashing at a very, very quick rate. It's flashing so fast that it appears to be on continuously. With the C1 capacitor installed right above the whistle chip, the sound is even lower pitched. it may sound more like a bug, such as a bee. I replaced the C1 capacitor with the C2 one, and now the circuit makes a very low-pitched humming sound. Kind of sounds like an airplane engine, depending on the pitch. I replace the C2 capacitor with the C3 one, and when I turn on the slide switch, the LED will flash and the speaker will make a quiet sound at a steady interval. You can change this interval by moving the lever on the adjustable resistor. You can make it the interval shorter or longer. And this is like a metronome that musicians use to keep time to music if they're practicing an instrument such as the guitar or piano. I'm going to turn on the slide switch, volume warning, and you hear a buzzing sound. And I'm going to move the lever on the adjustable resistor, and on some settings, the sound will resemble that of a foghorn. Depends on the pitch of the sound and the setting on the RV. On some settings, the speaker will not sound at all. I replaced the R5 resistor with the photoresistor, and when I turn on the slide switch, I can move the lever on the adjustable resistor to change the sound pitch, but I can also shine a light on the photoresistor and the sound stops. It either becomes quieter or stops altogether. And the more light there is on the photoresistor, the more resistance there is, and therefore the quieter the sound will become. I removed the photoresistor altogether and left the ends of these wires exposed, and I'm going to put my fingers between them with the slide switch on. You hear what might sound like an engine, such as from a race car. And the sound you hear might be consistent with sounds that you hear in an auto racing video game. Does it sound familiar to you? You can adjust the pitch and rate of the oscillator by adjusting the pressure of your fingers. If you wet your fingers, you might be able to make it sound better and louder too, as if you are accelerating the engine of your virtual race car, or you can reduce pressure and make the sound quieter as if you were braking in the video game. With the slide switch on, nothing happens. The red LED is off. But when I remove this black jumper wire on one end, the red LED turns on. This is a visual light alarm that sounds when somebody disconnects the black wire from the circuit. You could have a much longer wire and run it over a doorway or guarding something valuable, so that if an intruder attempts to enter or steal the item, the light will come on, although you might not see it if you're not in the same area as the circuit. but you could have another light connected to it in a place where you are, so that when the red LED comes on, that other light will come on as well, if you know what I mean. I'm going to push the press switch, and the fan will spin for a second or two, and then stop for a couple seconds, and then stop. I'm going to wait a short while, and then push the press switch again. The fan, once again, will spin only for a couple seconds before it stops. The capacitor is what is supplying the small amount of energy to the motor, and so releasing the press switch will allow it to charge, and then pushing it discharges the capacitor, allowing the motor to spin. That's why it only runs for a few seconds in this project. I replaced the motor and fan with the red LED, and when I push the press switch, the LED lights for a short while, and then it will gradually dim and go out. This project is called laser light because the LED acts like a laser that has emitted a very large burst of light, although it does not last too long. Now, in reality, I would use the 6-volt lamp, which would only be on for a much shorter period of time than the LED. But the red LED was the best that I could use in place. I'm going to put the exposed ends of the black and red jumper wires in this cup of water, and then I'm going to push the press switch. I want to make sure that they are not touching in the water, and then I'm going to push the press switch. Volume warning. The speaker sounds an alarm because the water, in this case, is completing the circuit when the ends of both jumper wires are in it. You can use other liquids such as distilled water, salt water, juice, milk, or soda, but I'm not going to do that. But you can try those things to see if they affect the tone the speaker produces. For this project, radio announcer, I'm going to turn on this radio. This might be loud, so please turn down your volume. And you may not hear anything. Now I'm going to talk into the speaker and listen to see if you hear anything. Hello? Hello? Can anybody hear me? Can anybody hear me? This circuit is pretty sensitive. You need to have the adjustable resistor and the adjustable capacitor, the CV, on just the right settings. Same for the tuner on the radio itself. Hello? You might be able to hear me then. What's up? Thank you for listening. Yeah, it's not perfect, but you can actually put your voice on air by talking into the speaker when everything is adjusted just the right way. This is going to be another water alarm. This alarm is more simple, and I'm going to turn on the slide switch and then submerge the ends of the two jumper wires in this cup of water. Volume warning. And the alarm sounds. Now really, I was supposed to leave the cup empty when I put the jumper wires in and then fill it. But it doesn't really matter. And you could ideally use this using longer wires to detect if there is flooding, let's say in your basement, and the alarm could alert you. This project is very interesting. I'm going to put this 2-snap wire over points Y and Z, and nothing happens, or nothing seems to happen. But I'm going to now move the 2-snap wire over to points X and Y, and the green LED lights for a very brief moment. It would not do that earlier. I'm going to quickly do it again. Look at that. The reason why the green LED lights up after placing the 2-snap wire between points Y and Z is because putting the 2-snap wire there actually charges the C5 capacitor. The capacitor stores energy, a small amount of energy, and then when I move the 2-snap wire to the left, the electricity discharges from the capacitor to light the LED. The capacitor basically acts like a battery. It does not store much electricity, but it is very useful for storing very small amounts of electricity, and they are found in advanced electronics like radios, televisions, computers, car electronics, and much more. I'm going to see how long the LED stays on when I have the C3 capacitor. It has less storage for electricity than the C5 one. I'm going to place the 2-snap wire there for a short moment and then reconnect it. The LED just blinks. I'm going to try it one more time. The 2-snap wire should not stay there too long to charge the capacitor. It just blinks, basically. I left the C3 capacitor in its place, but I put the R1 resistor in place of the R2 resistor. After charging the C3 capacitor, I'm going to now discharge it. And you may not have been able to notice, I'll actually replace the C3 capacitor, but the green LED is actually brighter than before because the R1 resistor allows more current to flow through to the LED. You might notice that it's a little bit brighter than earlier, since there is less resistance than in the previous two projects.